Hello dear students, so now today we would move ahead in this first chapter of class 9 science, that is matter in our surrounding. So here we are to discuss some more questions today. Question is, you have to give the reason of this. Question is, a gas fills completely the vessel in which it is kept. So what is the reason for this? Why? Let's say you have gas and you are filling the gas in a vessel here. Okay. So some amount of gas you are filling here, but the gas is taking the whole space inside. The gas is going to fill the complete vessel. You are just filling only some amount there, but the gas is going to take all the space inside there, isn't it? Means, let's say you are filling some amount of gas, and the gas would, let's say in case of the water, let me tell you the example. Let's say you take the water and you are filling some amount of water here. So only this much amount of water you are just filling here. So the water would take only this much space, isn't it? Now if the same amount of gas you are filling in this one container, the gas is not going to take only this much space. Rather, the gas would take the whole space inside. In case of water, the water is taking only this much space, but the gas is taking whole space inside the vessel. Why this is so? Now let me tell you the reason. We have discussed the particles of solids are very close to each other. Why? Because the force of attraction by which they are binding each other, okay, means this one particle would attract this one particle and this one particle would attract this one particle. So they are binding each other. So force of attraction is maximum here in case of the solid. So in the particles of solid, the force of attraction between the particle is maximum. And in case of the liquid, the force of attraction is somewhat lesser, means lesser than this, isn't it? In case of the liquid, the force of attraction between this particle would attract this one, this particle would attract this one, but the force of attraction would be lesser than this. But if you see in the case of gases, the force of attraction is negligible, you can say zero, minimum force is there. So that is why the particles are here and there. They are not attracting each other, isn't it? They are just moving here and there and colliding with each other. Let's say this particle is moving and colliding with this, then this particle is colliding with this, okay? So here the force of attraction between the particles is minimum, okay? So because the force of attraction between the particle is minimum, so no force of attraction is between there. So that is why if suppose 10 particles of gas are here, 10 particles. So these 10 particles would not have the attraction between them. So that is why they are going to go here and there. They are going to fill the complete vessel. Are you getting this? But this is not in the case of liquid. Liquid, if you have fixed number of particles, so these particles are going to fill the fixed space because they have the force of attraction there. They cannot go the particles cannot go here and there everywhere. Why? Because the particles are binding each other. They are attracting each other. That is why all liquid will be at the same place. Similarly, in case of the solids also. Okay. But this is not in the case of gas because the particles of gases have minimum force of attraction between them. So because the force of attraction is not here, minimum is there. So one particle would be here, one particle would be here, one particle. So that is why they are going to take whole space. And one more thing, the particles are continuously moving. Here they do not have much space to move. They cannot move. Here they have some space to move, but there have enough space to move. So they can move here and there everywhere, wherever they want. The particle can move here everywhere. So the particles are moving also everywhere and they have no force of attraction between them. That is why the gas which you are filling in this one container would be taking the whole space inside. This is the reason. Are you getting this? Okay, let me write this now. So this is the answer you would write. Okay, a gas is filling the complete vessel. Reason is, it is because the forces of attraction between the molecules of the gases is negligible because they have no force of attraction. That is why they are filling the complete space. Okay. Getting? Means the available space, total available space, they are going to fill the maximum space there. And one more reason, high kinetic energy is also there because the molecules of the gases are continuously moving here and there. So they have the kinetic energy. Okay. So the kinetic energy of the molecules of the gases is very high. That is why they are moving here and there in the complete vessel. Okay. So these two reasons are there. First reason is what? They have negligible force of attraction between them. Second one reason, they have high kinetic energy also. So because of these two reasons, the gases are going to fill the complete vessel. Isn't it? Okay, just note it down. Now the second question is, a gas exerts pressure on the walls of the container. Why? Again, the next question. You have a container, and inside the container, or let's say it's a cylinder, so it contains some amount of the gas. So the gas is going to exert the pressure on the walls. Okay, because as soon as you just pin here, okay, make a hole there, so complete gas would be coming out from here, isn't it? Okay, so the gas which is inside is going to exert the pressure on the walls of the container, isn't it? Whatever the gas is there inside, so it is exerting some pressure there. Okay, means it is trying to come out, isn't it? So the gas which is inside is exerting the pressure on the walls. This is the wall of the container. So the gas is exerting the pressure on the walls of the container. Why it is so? Why the gas is exerting the pressure? See, we have discussed. We have the molecules of the gas here. So these are the molecules of the gas. As we have said, the molecules of the gas are just continuously moving here and there with high kinetic energy. So these molecules are continuously moving. Let's say it is moving here, then here, then here, then here, then continuously moving here and there, isn't it? So on doing this, so the molecules are colliding with each other also, isn't it? Let's say this is the molecule, is moving from here to here, and it is colliding with this one molecule, then coming here, then colliding with this one, then going there. Means this is how the molecules have a random motion there. They are going here and there, here and there, here and there. So on doing this, so they are going to apply some force on the walls also. Let's say you have the molecule here, so it is moving with very high speed. So during this process, it is going to exert some force on the walls. Let's say it is colliding with the molecule and going there, so it would exert some force in this one wall, then it would go there, then it would go there, then it would go there. Okay, so this is how the molecule would continuously move, or would continuously move inside the vessel, isn't it? So on doing this, so the molecules of the gases are exerting the pressure on the wall also, exerting some force there. They are applying, because the molecule is there, it is continuously moving with very high speed. So while it is moving, is exerting some force on the wall also, isn't it? So while doing this, so that is why we are experiencing some pressure on the wall there. Okay, so that is why we say that a gas exerts pressure on the walls of the container. Why? Because the molecules are moving with very high speed on this, so on doing this, so they are colliding with the walls also, and they are exerting some force there. Okay, so this is the force. This is the force which is the pressure there. Okay, so the molecules are applying some force on the container there, walls of the container. Okay, we call it as the pressure there, isn't it? The force that they are applying per unit area. Let's say you have the molecule, so in this one area, this is the per unit area. How much force has been applied here? So this is called as the pressure. Let's say we have the molecule, and this molecule colliding with this one wall. So in a unit area, in this, let's say in this one area, how much force the molecule is applying? So this is known as the pressure, isn't it? Okay, so that is the reason. Let me write it. So this is the reason. Okay, reason is what? The motion of the particles, the motion of the particle is random. Okay, because they are moving here and there and having very high speed also. So in the gaseous state, so due to this, the random movement, due to this random movement of the particles, okay, of the particles hit each other, and also the walls of the container, the pressure exerted by the gas is due to this one force exerted by these particles per unit area of the wall. Okay, so that is what you have to write it. Okay, I have already explained this. So the main reason, you can say, why they are exerting the pressure on the wall, the reason is what? In simple, if you want to say, the reason is due to the high speed of the particle. The particles have very high speed, and they are colliding with the walls also, colliding with the particles also. So that is why they are exerting some force. The force exerted per unit area is known as the pressure. So that is why the particles of the gases are exerting pressure there. Okay, so this is the complete reason you have to write there. Okay, that is all for today. Would be discussing some more questions in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.